So what we will also do ourselves in the next session is this 5G as a service specification design. So some history on that. You will be provided also the slides after this break, so you will have the links towards all the slides. We had an initial OSL 2 Tech Day back in February 2024. So this was at this Tech Day, which is also recorded and available at the YouTube channel of OpenSlice. We had the Release 0 installation walkthrough. Release 0 was the release that we have ported from GitHub, and it was before the first initial release of OpenSlice under Etsy. We had the simple usage walkthrough of OpenSlice, but this was extremely NAV-based. So we had an NAV-based simple deployment of a simple NAV artifact, namely NNSD, through OpenSlice, but also we have created a more complex NAV service, NAV-based service, and deployed based on the version that we were aiming to develop towards the first release. As you can see, it's 2024 Q2 snapshot. So it was the objective of the first release. As I've said, the videos are available at YouTube for that. So what we have done there is to provide a service, a bundle of service named under 5G connectivity and internet access that will also accept user input. This service comprised of a UPF service, which was CNF-based and deployed the UPF network function through OSM and through Kubernetes, as you may have seen in the past. It comprises a 5G core network service, which was again CNF-based, and it was deployed through OSM and eventually Kubernetes, which deployed the rest of the 5G functions. And also we had, let's say, a standalone third service, which connected the radio nodes, the selected radio nodes, towards this newly deployed 5G instance. So this actual service was just an HTTP request, and this is the reason, for example, that Awesome is providing with BPMN diagrams that execute HTTP requests, for example, because it was outside the deployment world. An HTTP request towards a radio management server that manages in a proprietary way the radio nodes in University of Patra's facility. So in illustration of this demonstration was that the user orders this service specification from the catalog and inputs some specific parameters, as you can see. A 5G radio node, some deployment characteristics of a 5G system, which is mobile country code, mobile network code, etc., and some run profiles in terms of profiling the traffic that someone would need to accept. So the 5G connectivity services first deployed the UPF network service, injecting a unique order ID in it so as to differentiate it with simultaneously deployed orders. Because as you may be aware of, you couldn't deploy the same services in sense of naming in the same namespaces in Kubernetes. So this order ID was delegated to OSM through the instantiation, let's say, payload, which was respectively delegated to instantiating the service at Kubernetes level. So the order ID was used as a namespace so as to differentiate different 5G instances in the same Kubernetes node. So when this UPF service was active, then the UPF deployment IP was retrieved from OSM and was exposed towards OpenSlice, which was passed towards the next service, which was the deployment of the 5G core. So the 5G core wanted the IP of the UPF so as to connect to. So this happened with LCM rule. We'll see some examples later this day. Again, this deployed the rest of the 5G core functions in Kubernetes, and the AMF IP was extracted in the same way as the UPF IP deployment. This was again a prerequisite for the next service, the Connect Radio service, because the Connect Radio needed the AMF IP so as to connect the respective G-node beast against it. So the Connect Radio, what it actually did is to provide an HTTP request towards a radio control agent that it is, of course, implementation specific, in Patras testbed, that will interact with the respective G-node Bs that the testbed provides based on the 5G radio nodes input that the user provided, and connects respective G-node Bs towards the newly deployed core. So what we would like to see at this Hackfest is this exact scenario minus the connect radio, because apparently it is difficult to have it here, but migrated towards cloud nativeness. So we'll have the same exact service, but based on the development branch of OpenSlice. So we'd like also you to have a sneak peek on what we are going to deliver on the next release. And it also comprises of two services, a UPF, which is now CRD-based, and it's not deployed via OpenSlice, OSM, and the remaining of the core, which is again CRD-based and deploys the 5G network services except UPF. So again, the user can order this 5G connectivity service. The rule will inject the order ID towards the UPF, but this will go through and enable or wake up an Argo CRD, namely the kind application of Argo CD, that will deploy the respective service against the Kubernetes cluster, again giving it the namespace of the order ID. When we have the UPF IP extracted, deployment IP extracted, we can instantiate the core network service. And again, this through the Argo CRD will deploy the remaining of the core. And this will be what we will see at this Hackfest, but also we'll see some feedback towards the user. So after the core is being instantiated and the 5G web UI of this core is available, you will see it at the ordered service, and you will actually have the possibility to also browse and log in at this. So this will be the demonstration, and now I think we can have a break so as not to extend this first session. So I think this would be it. Any brief questions? Okay, yes, please.
Okay, thank you, Kostas. Just a question. You're saying that the core network needs the UPF IP address? For what reason?
Okay, so if it is the network or the whole 5G system, it is deployed in the same cluster, then actually it is not needed, given the fact that it can be actually extracted by core DNS, for example, within the cluster. But the core needs the UPF, or I would say, actually, let me reason on the reasons that we would like to provide it externally. But if you have a UPF deployed elsewhere, or you want to connect more than one UPF, which is deployed in another Kubernetes cluster, you will have to have it as input. So to answer your question now, the core needs to provide or register the UPF in the network function registry that it has, so as to provide the GTP tunnel that needs to between the AMF and the UPF. If I'm not mistaken, this is the N6 interface. So the UPF connectivity towards the core is needed so as the UE can communicate with and provide the services. Yes, sure.
I'm just asking because in a real 5G network, it's the other way around. It's the UPF that wants to know the IP address of the NRF in order, to register and to find the SMS and, things like that. So it looks a little bit weird that you want the IP address of UPF in the core network. I would assume it is the other way around, that the UPF needs to know the IP address of, the core.
Actually, the process, though, is instantiated the other way around. When the core is deployed, then it issues a PFCP command towards the UPF address, and then, as you said, UPF registers to the core. So the control plane message is instantiated through the core, as I have seen in our example, for example. So it is only possible to connect or instantiate the handshaking, I would say, request when you know the UPF address. But yes, as you said, the UPF connects to the core, but the control message is sent by the core itself to connect. Yes, most probably. Actually, we have a demo tomorrow that I think we have this thing exactly captured. Most probably, you know, the majority of the applications, given the fact that they deploy everything in a single cluster, maybe miss this control message and actually go directly to the logs of UPF and see that, as you've said, UPF tries to connect to specific AMF address.